This is a video presentation on cardiovascular fetal development. Starting off here, we're going to talk about the case. We're up here, by the way. Let me get a pointer. Hold on. There's a laser pointer. Okay, so embryonic dilatation, Truncus arteriosus. The Truncus arteriosus, if you look down here, it's this structure. See, when the heart first forms, it doesn't look like a heart at all, and it's like upside down and backwards, basically. So up here is the Truncus arteriosus. This eventually will become the aorta and pulmonary trunk. So basically, this thing here is going to like fall over. See this? Whomp. And when it falls over, it ends up having the aorta and pulmonary trunk like on the opposite side, like down here. Okay, so sorry, not on the opposite side. They're still on the top there, but it's down like this. If I were to kind of draw a picture of what that would look like, there's actually a condition where a person let's get here we go, black screen. Okay, so, and I'm gonna need a pointer. So how about a pen? Here we go. Okay, so here's the deal. So let's say here's a heart. Okay, you got your right atrium. This is not anatomically correct. This is oops. Okay, pretend that says right ventricle, and this is your left ventricle. Okay, so basically here's what's going on. So this is like upside down and backwards, but it's easy to see kind of what's going on. Right atrium, left atrium, right ventricle, left ventricle. Okay, you kind of see that? So what's going on here is essentially over here on this right atrium, you have blood coming in from the body, deoxygenated blood. It's going to go through here, through the tricuspid valve, and then it's going to go into the right ventricle, and then it's going to get pumped out through the right ventricle, through the pulmonary valve here, and then it's going to go into the lungs. Okay, and then from the lungs it's going to come in through here, and it's going to come in through here through the mitral, into the left atrium, and then it's going to pass through the mitral valve, and then it's going to go into the left ventricle, and then the left ventricle, which is big and strong and powerful, is going to push this out through the aortic valve into the aorta, and it's going to go to the body, and then it's going to go from the body around back through here, and it's going to start that process over again. See that? Like that. Okay, over here. Okay, so that's kind of what's happening there. In the case of a Truncus arteriosus, essentially what's happening is that when this thing is developing, when that top part is developing, you're going to get kind of would look like this. Before I had it drawn like these separate, but instead they're together in one giant one that comes down. So like both of the chambers drain their blood, and the oxygenated blood and the deoxygenated blood combine together, and then they deoxygenated and oxygenated blood come out here. So sometimes, you know, this doesn't happen properly and it stays together as a Truncus arteriosus, and when that happens, the person would, you know, have cyanosis and all those sorts of things. So that's the Truncus arteriosus. You kind of see how that's developing. It becomes this later on. This part becomes this. Next, the bulbus cordis. The bulbus cordis is going to develop into the smooth parts, the outflow tract of the left and right ventricles. So here's the bulbus cordis, this kind of bulbous looking thing here. This part is going to end up being on the bottom, okay? Which makes sense if you just backtrack a little bit here. Remember the Truncus arteriosus here? This becomes the aorta and the pulmonary trunk. Well, what is it that squeezes blood into the aorta and pulmonary trunk? The ventricles. The right ventricle pumps blood into the pulmonary trunk, and the left ventricle pumps blood into the left ventricle. So this bulbus cordis, which is the next part here, is going to be the part that becomes the ventricles down here, okay? Left ventricle and the right ventricle and all that stuff. Conus arteriosus and aortic vestibule. So that's the adult parts. Next we have the primitive ventricle, okay? So that's just below that. This is like the actual ventricles themselves. The other part was kind of the margins of it. They described it as the conus arteriosus and the aortic vestibule. But in this case, it's the actual full. And look, it's the very next thing here. So this is the big ventricle itself. So this becomes the right and left ventricles. It ends up getting divided up later. We'll talk about as this thing forms, the septum. But this becomes, the primitive ventricles become the left and right ventricles, a trabeculated part of right and left ventricles. So here it is, the ventricles. Next, the primitive atrium. The primitive atrium is going to turn into the trabeculated part of the right atrium and the trabeculated part of the left atrium. So up here you've got your atria, and down here you've got your ventricles. So left atrium, right atrium. You can see here the primitive atrium. See how this part, when this part flops down, this ends up being on top. See that? Up here, it's on top. So it was down here at the bottom, but when this flops down, this ends up being on top, and that's why your atria are on top. Now the sinus venosus, the left horn of the sinus venosus, becomes the coronary sinus, which I drew a better picture of right there. And the right horn of the sinus venosus becomes a smooth part of the right atrium. So here's the right atrium right there. So it turns into the smooth part of the right atrium. And that's this part down here. This is the sinus venosus. So this thing here actually stays kind of in the same place. And everything sort of flopped down. This part here becomes the atria. This part up here becomes the ventricles. This part becomes, you know, the thing that leads into that, the conus arteriosus and the aortic vestibule. And then these cords kind of develop down and they turn into the vena cava and the aorta. And there it is. That's the first part. Now let's talk a little bit about some of these atrial septal defects that occur. So first of all, septa. What are these? Here's the ventricular septal. So this would be a ventral septal. And there's also a septum that divides the atrium as well, similar to this one. Okay. So basically, it keeps the blood separate between the atria, if it's an atrial septal, atrial septum, and between the ventricles in the ventricular septum. So this can be really bad if it doesn't develop properly. So let me kind of show you what would occur in the case of it not developing. So if it doesn't develop, you're going to have mixing of blood. So here is a simple diagram of the heart, and right atrium, left atrium, right ventricle, left ventricle. So normally there's this septum that divides these guys here, and then there's, you know, this there, and there's your open with valves. You get your tricuspid valve here, and you've got your mitral valve there, and then this goes out, you know, into this is the pulmonary trunk here, and then this here is going to be the aortic, and this is where it's draining in, and this coming from the lungs, this is coming from the body. So normally there's a nice division here, but sometimes you have a defect, and this defect is where you don't have a division between the atrium or through the ventricles. And when there's no division, as the blood gets pumped through here, you know, this is a high pressure system. It says that the ventricle first, I guess. This is a high pressure system pushing blood through the ventricle, through the aorta, through this aortic valve here. And this is a lower pressure system. So when this squeezes down, if there's a hole right here, then it'll squeeze blood, oxygenated blood, into the right ventricle. And that's going to put a lot of pressure here on this right ventricle because it has more blood. And that pressure is going to end up going into the lungs, and you may end up getting pulmonary hypertension. And when the pulmonary hypertension gets enough and this pressure just gets so great, it's going to actually shunt now from the right to the left. And you're going to end up getting deoxygenated, because this blood in here, remember this comes from the body down into here, this deoxygenated blood will actually come across through this ventricular septal defect, come into here, and you're going to be sending deoxygenated blood into the body. And so you're going to see cases of cyanosis. Atrial septal defect, similar story. Basically what happens is that, you know, the blood comes down through here. When it comes down through here, again, this is a higher pressure system. If there's a hole right there, then the blood's going to go this way. And when the blood goes this way, it puts more pressure on this right atrium, which means more pressure on this right ventricle. And so you're going to hear a S2, you're going to hear like a split S2 sound. And the reason for that is because this valve right here, the pulmonary valve, is going to have so much pressure on it that it's going to close a little bit after the aortic valve, and so it's going to have this split S2 sound. Okay, and of course this also has, you know, bad repercussions. Eventually this gets so backed up that, you know, it could go this way. Same kind of thing as before. So discussing a little bit more about these atrial septal defects, there is I'm just going to go ahead and read this to you. It says this is actually backing up a little bit. I guess I'll just let you read that on your own. But going down here, atrial septal defects. It says that there's a secundum type. These are caused by excessive reabsorption of the SP or reduced size of the SS or both. Okay, so you go over here. SP is the septum primum. So in other words, what you have is your septum primum becomes reabsorbed. This is the thing that becomes the septum here. So this thing here, septum primum, gets reabsorbed. And then there's a septum secundum, which is the second one that comes down. This one ends up kind of covering it up here, the hole. And the septum secundum, that one also can be reabsorbed too much. And so if your septum secundum type, ASD, is basically where these things, you know, get reabsorbed. And so what happens is if this gets reabsorbed, then there's still this hole here. And it says clinical symptoms can be delayed as late as age 30, which is amazing. So the foramen ovale, is a little hole that allows communication between the right and left atria. So up here in your atria, there's this little hole here, the foramen ovale. See that little hole? And that remains open in 25% of individuals throughout life, although paradoxical emboli. So when I say paradoxical emboli, let me explain really quick what I mean by that. Let me go to a screen here. So basically, you have typically when an embolus forms, it is going to be coming in. So here's the heart again. Right atrium, left atrium, right ventricle, left ventricle. When an embolus forms, typically it comes from the body. And it comes in here, and then from there it's going to, you know, travel down and get stuck in the lungs somewhere. But if you have a hole right there, this emboli from the body can come in through here, pass this way, go into the body, and instead of the lungs, go into the body. Sometimes get stuck in the brain or something like that. And that's what they're referring to when they talk about these. Where was I in the reading? When they talk about these paradoxical emboli. So they pass through the foramen ovale and then they go into like the brain or something. So the premature closure of the foramen ovale is the closure of the foramen ovale during prenatal life. This results in hypertrophy of the right side of the heart and underdevelopment of the left side. So you wonder, you know, why does that happen? Well, normally the foramen ovale is supposed to close kind of late on, you know, right before the baby's born or whatever. But prenatally, when the baby's in there, if it closes too soon, if this septum primum grows down, you know, too fast, second secundum grows down too fast and covers this up early on, then what's going to happen is that all of the work of the heart is going to be relied to happen here as opposed to, you know, coming down here and doing this. And so you're going to have hypertrophy on the right side of the heart, and the left side, because it wasn't getting the blood, is going to be underdeveloped. Remember, the infants have something called the ductus arteriosus that connects things a little differently than in the adult heart when it's supposed to close, unless you have a patent ductus arteriosus. Okay, so let's talk about some of the development here. So the atrial septum. So what happens here is the septum primum grows towards the endocardial cushions, narrowing the foramen primum. It's the first thing that happens. So this is the septum primum here, this little thing, and it grows toward the endocardial cushions. Here's the endocardial cushion. These grow together. So this is the right atrium, left atrium. This would be the septum that divides it, but it hasn't developed yet. So this septum primum grows down and starts to create this little thing here. Another illustration of it over here. So next, the foramen secundum forms in the septum primum. So here's the foramen secundum here, and this is the second hole, or whatever, foramen hole, secundum, second hole. This is the first hole, okay? The foramen secundum forms in the septum, Foramen secundum forms in septum primum. So here's the septum primum, and now you get this little thing forming here, and it's gonna have yeah, you can see actually the diagram shows it perfectly here. So now you got the foramen primum, foramen secundum, and next the septum secundum develops as the foramen secundum maintains right to left shunt. So here's the right to left shunt, and the septum primum now, that main hole, like you see, it's this thing here is growing up, and this is the foramen secundum now coming down like this, coming across here. And also you get the development of the septum secundum. So this septum here is starting to grow. Now in the foramen secundum, the next step is the septum secundum expands and covers most of the foramen secundum. So now this thing here that started to grow, it gets a lot bigger, and it goes all the way down, and it covers up this foramen secundum. So now this hole is covered. And the residual foramen ovale is the foramen ovale. So this last little bit here, last little hole that you got there, ends up being the foramen ovale, a little tiny hole there, because this septum secundum came down and covered it up. Now the remaining portion of the septum primum forms valve of foramen ovale. So they're going to have this little valve here, and it's closed there, foramen ovale. So this remaining portion of the septum primum, so this little bottom part, this is the septum primum right here, this thing lifts up and kind of covers up as a little valve that's closed there. And the septum primum starts to degenerate, which is not really showing too much. Not shown septum secundum and septum primum fuse to form the atrial septum. So eventually the whole thing fuses together, and it forms the atrial septum. And also explains here that the foramen ovale usually closes soon after birth because of increased left atrial pressure. So left atrial pressure, this little thing is a valve. This pressure gets really high. It's going to push this on here, and it's going to close that. Okay. So if the pressure was higher over here than over here, then it would stay open. Because it's higher over here, it pushes against it. And a note here, it says patent foramen ovale, which means open foramen ovale, caused by failure of septum primum and septum secundum to fuse after birth. If this thing never fuses, then you're going to get a patent foramen ovale. Most are left untreated, can lead to paradoxical emboli, which is where I explained that earlier, venous thromboemboli that enter the systemic arterial circulation. Okay, now we're going to talk a little bit about ventricular septum. So, same kind of idea as the atrial septum, except for this is now in the ventricles, and it forms totally different. Because remember, going back up here to the early development, the ventricles formed by this whole thing flopping over, whereas the atria were just right here the whole time. So this is going to be a little bit different than the other one was. So it's a membranous ventricular septal defect, is caused by the failure of the membranous interventricular septum to develop, and it results in left to right shunting of blood through the interventricular foramen. Patients with left to right shunting complain of excessive fatigue upon exertion. Totally makes sense. I mean, imagine if your oxygenated blood was shifting from your deoxygenated blood, shifting from your right ventricle into your left ventricle, now getting pumped into your body. Your body's not going to have enough oxygenated blood because it's mixed with the blue blood. So the left to right shunting of blood is not cyanotic, but causes increased blood flow and pressure to the lungs, pulmonary hypertension. Pulmonary hypertension causes marked proliferation of the tunica intima and media of pulmonary muscular arteries. These are just layers. This is, just describing things. Basically, the pulmonary resistance becomes higher than systemic resistance, causes right to left shunt of blood and late cyanosis. So originally it was, I kind of showed this earlier. But originally what was going on here was that you had the blood going, this is where the hole is, the blood going from here to here until the pressure here gets so high that then it pushes it this way, and then you get cyanosis. Okay, so I'll just go ahead, maybe I'll just keep a pen here. So now we're talking a little bit more about some of the heart morphogenesis. So in this case, this is showing how these ventricular septal defects occur. So in the beginning, the muscular ventricular septum forms. So interventricular foramen, there it is. Okay, so opening is called interventricular foramen. So this opening here is the interventricular foramen. What are we looking at exactly here? Here's another diagram of kind of what we're looking at. Here's another way that it's displayed. After that septum forms, so there's that hole there, the septum. What ends up happening is up here things get kind of interesting, twisty tied around. And it says the aorticopulmonary septum rotates and fuses with the muscular ventricular septum to form membranous interventricular septum, closing the interventricular foramen. So here it is this thing rotated and fused with the muscular ventricular septum. So here is the muscular ventricular septum. This thing just rotated and fused with it. So, and that closes the interventricular foramen. So that interventricular foramen that we had here got closed off. Now, in the growth of endocardial cushion, so we're looking at the endocardial cushion. This thing's basically, there's another diagram of it showing here, that cushion there. It separates the atria from the ventricles and contributes to both atrial septation and membranous portion of interventricular septum. So it helps to separate those things out. It's this guy here, membranous interventricular septum. Now we're going to talk next about Truncus arteriosus and kind of what happens with that. Well, maybe I'll skip over this part a little bit. These three things are the next thing we're going to discuss. Don't worry about that for now. Okay, so first of all here, the transposition of the great vessels. So basically, if you've got this, you have your right atrium, your left atrium, your left ventricle, and your, your right ventricle. Apologize, looks terrible. And your left ventricle. Basically what you're going to have here is transposition of the great vessels means, see these big vessels here? This is the pulmonary trunk, and this here is the aorta. Okay? Normally, blood comes in through here from the body, comes down through here, blue blood, and then it's going to go here to the lungs where it gets oxygenated. And it's really hard to write with a mouse. And then it's going to go from the lungs in through here, from the lungs into left atrium, come down through here, past there's valves here by the way, passes right here through the mitral valve, comes down here, goes into the body, and then it goes from the body kind of up through here, back there. So it's like makes like a figure eight, right? Kind of has this kind of form from it. It goes lungs. And then, you know, out, around, goes to be, yeah, it just kind of makes this kind of figure eight almost. So when you have a transposition of great vessels, you take this vessel here and this vessel and you swap them. What I'm saying here is that it goes from the body to the right atrium, right ventricle, to the body. Body to body, that's not good. That's just making a loop here. And on this side, it's going to go from the lungs, come down here, left ventricle, or left atrium, left ventricle, not the body, back to the lungs, and just making a loop here. So this blood is always oxygenated, and this blood is never oxygenated. The person's going to die. Now, the only thing that's keeping them alive is the fact that you have here, in the baby, while they're a baby, they have something called the ductus arteriosus, and that connects these two tracts together. So when the blood comes down through here, it can go across here into the lungs, you know, and then it can get oxygenated or whatever, and you know, you can keep the baby can stay alive. while it's in the body. Now, as soon as there's a change in the prostaglandin E, and this thing shuts down, prostaglandin E goes away, this baby's going to die really quickly. So what's the treatment for this? What you're going to do is you're going to give them prostaglandin E to keep this open, and then as soon as you can, you're going to do surgery and you're going to swap these vessels around, get them the right way. So I'm just going to read what it says here. It says occurs when the AP septum fails to develop in a spiral fashion, results in the aorta opening into the right ventricle and the pulmonary trunk opening into the left ventricle. Bad news. This causes right to left shunting of blood and results in cyanosis. Infants born alive with this defect must have either other defects like patent ductus arteriosus or ventral septal defect, ventricular septal defect, that allow mixing of oxygenated and deoxygenated blood. Otherwise, if the mixing doesn't occur, the baby would die. So tetralogy of Fallot. This is the next one here. This is actually several things that are wrong. They got 4 things here. So I'll draw it out. We have right atrium, left atrium, right ventricle, left ventricle. This is coming from the body, going out to the lungs. This is coming from the lungs. It's going out to the body. Okay? So, what's happening here is that the first thing you have is something called pulmonary stenosis. So right here, this little opening, normally it would be like nice and big. It's not nice and big. It's very narrow. It's stenosed. So there's not very much blood that can get through there. So this is like narrowed down. That's the first thing. The second thing you have is something called an overriding aorta. Okay, so this is the aorta here. That is overriding. Next, 3, you have interventricular septal defect. So down here, in the ventricles, you have a defect, which means there's a hole here, which means the blood gets shunted this way. So what I'm saying is that deoxygenated blood comes through here and goes this way and sends deoxygenated blood down into the body, and not very much blood goes this way. So this causes a right to left shunt, which is what I showed there. And the last thing is here is you have right ventricular hypertrophy, which makes sense. This ventricle is having to push blood through a tiny little hole. So it has to get really, really strong and thick in order to have enough power to squeeze the blood through that tiny little hole. So you get right ventricular hypertrophy. Also, the blood from here is going this way, which is putting extra strain on it. So it has to get extra big and strong to actually be able to push the blood out this way. So what you're going to see with this one is a lot of times the baby will squat down, and when you see the baby squatting down like that, what the baby's doing is it's increasing the aortic or the arterial pressure, which is going to kind of almost allow some of the blood to go this way instead of this way, so the blood can get oxygenated. And you're going to see early cyanosis. Okay, now with persistent Truncus arteriosus, what's happening with this one is that it's basically what I explained earlier. So earlier on, remember you had that weird looking, I should just go up to it. Oh boy, what's way? Here it is. Here's your Truncus arteriosus. Okay, basically, eventually, this tube and this tube are supposed to end up like, you know, here and here on the heart, going into the atria, but instead they stay together as this big thing here, and so the blood gets all mixed up together, and you end up sending oxygenated or deoxygenated blood mixing in with the oxygenated blood, and the baby ends up pushing blood into the body. So if you draw a diagram here, upside down kind of. So rather than having one valve there, one valve here, what you have instead is something like this, and then it separates. Okay, and that's everything.